As I mentioned before, pointers are a great boon to using structures and functions together because they make the whole deal much more efficient. They make it faster and they make it use less memory. So how do they do that? Well, let's talk about why structures are so inefficient when it comes to using them as function parameters. Imagine you've got a structure, let's say a CD structure, the one that we are using in our course project. How many bytes is one structure? Well, it's 60 odd bytes for the artist, another 60 bytes for the title, and let's say another 15 bytes or so for the rest of it, the number of tracks, the price, and the flag, the Boolean flag. So that's 135 bytes roughly altogether. 135 bytes. Now that's actually quite a small structure. Most structures for such things are much, much larger than that. You could have a structure that it would be conceivably a couple of thousand bytes or a couple of kilobytes, if you like. And now it comes time to pass that one of those structures to a function so that the function can do something with it, such as print it out or whatever. So what happens? Well, as you recall, every function parameter is actually a duplicate of the original. So firstly, we have to create another 135 bytes or 2000 bytes or however big the structure is. They have to be created in memory. So in other words, the program's now going to start using an extra 2 kilobytes of memory that it wasn't using before. Now once that extra bit of program memory is set aside, the structure, our original structure, must be copied into it. So copying a couple of thousand bytes is not just the same as saying, x equals 5. All you're doing then is you're setting 4 bytes. Setting 2000 bytes actually takes an appreciable amount of time. If you make a habit of this, all these function parameters, setting them aside and copying them around can add up to quite a few extra kilobytes of memory, maybe as many as, say, 500 extra kilobytes, maybe, and passing them around may cause your program to run, say, 10% slower. Now, we don't want that. So instead of passing a structure into a function, you pass a pointer to a structure into a function. And instead of then, that means, of course, that instead of passing in 1,000 bytes or 2,000 bytes or however big the structure is, you're now passing in only 4 bytes. 4 bytes being the memory address. So you only have to create 4 more bytes of memory, and you only have to do 4 bytes worth of copying, so it's much smaller and much faster. Now, if that was all there is to it, then we really wouldn't have much of a discussion when it comes to pointers and structures. You'd use them in exactly the same way as we saw in the previous example of passing the address of an integer in to the double-it function. We'd just pass the address of a structure in to whatever function that we were using, and then we'd use the asterisk to, well, we call it to dereference the pointer, to find out the thing that the pointer is pointing to. But there is a little bit more to it than that, because structures have fields. Remember, like the age field or the name or the address field or whatever it is that we're talking about, the artist field, the title field. So we'll have a look at those fields now. Let's summarize. Manipulating pointers to structures is exactly the same as manipulating pointers to anything else, including passing them as parameters to functions. There is nothing new to learn about that. But when it comes to fields, it's a slightly different issue. Consider the following. Let's say we've got a structure called struct employee, and we declare a pointer to it, and we'll call that emp_p, or emp employee pointer. Now, look at the second line of code there. Emp_p, so the employee pointer, .age equals 34. Now, that line of code will not compile, because emp_p is not a structure. It is a pointer to a structure. And the dot operator, the little dot between the emp_p and the age, the dot requires that the thing on its left be a structure. That's the little rule. The thing to the left of a dot must evaluate to be a structure. Now, emp_p is not a structure, it's a pointer to a structure. So that line of code, emp_p.age equals 34, will simply not compile. So we need to fix it. How do we fix it? How do we fix it so that instead of producing a pointer to a structure, we produce just a structure? Well, how about *emp_p? *emp_p. Think about if that's confusing to you, think about it in terms of integers. If you've got an integer called x and a pointer to an integer called ptr, then star ptr or asterisk ptr will be an integer. Ptr itself will be a pointer to an integer, while asterisk ptr will be an integer. So hopefully in a similar way, asterisk emp will be a structure. Let's have a look at that. Star emp.age equals 34. Well, we're on the right track now. This is exactly what we're supposed to try and do here. However, that's not going to compile either, but for an unexpected reason. It turns out that the precedence of dot is actually higher than the precedence of asterisk. So if you don't remember what what it is, what precedence is all about, or what I could possibly be talking about, well, I've got two operators here, an asterisk operator and a dot operator. And the dot operator has higher precedence, so that will be evaluated first. So what this will essentially look like is this. I mean, the brackets aren't there, but the compiler will treat it as if the brackets were there. So everything inside the brackets gets evaluated first. emp.age, well, that's just simply not going to compile for exactly the same reason as the very first example didn't compile, because emp is not a structure. It's a pointer to a structure. So emp.age won't compile, and even if it did, taking the contents of that, by putting the asterisk at the beginning of all of that, it wouldn't make sense, because age is not a pointer. Age is only an integer. It may be worth rewinding what I just said and listening to it again, because it is a little confusing, I know. Anyway, the point is that will not compile. But it's quite easy to fix by the use of brackets. You can do it like this. You can put the brackets around the emp and the asterisk. So now that reads, take the contents, or take the thing that emp points to, and that's obviously going to be a structure, and then find the field of that called age, and set that to 34. And that will work. That is perfectly okay. And it will. It'll compile and it'll do exactly what we want it to do. However, this syntax is clumsy. Having to put these brackets around there and all of that, the asterisk and the dot, it's just a little bit out of control. And there is a nicer way. They've invented a shorthand that does exactly the same thing. And it looks like this. emp minus sign greater than sign age. And you can treat the minus sign greater than sign as an operator called pointer, or pointing to, or field of, or whatever you want to call it. It looks like a little arrow, doesn't it? A little minus sign and the greater than sign. It looks like a little arrow. In fact, it looks like a little pointer. So it's quite easy to remember that you use those with pointers. Compare this with what we just had on the previous slide a moment ago. Brackets star emp close brackets dot age. Instead, we've got emp pointing to age. It's much simpler syntax. So to summarize this, if we're trying to find one of the fields of a structure, we use a dot. And if we're trying to find one of the fields of a pointer to a structure, we use the minus sign greater than, or the pointer arrow. The arrow, we'll call it the arrow. So you either use the dot or you use the arrow, depending on whether the thing to the left of it is a structure or a pointer to a structure, respectively. Okay, let's go and have a look at some examples of that. Here is struct.c. Now this has just been copied from our previous exercise on structures, the one surrounding employees. And remember, we had a little function here to read in an employee and to print out an employee. And there's the main. We've got emp1 and emp2 and so on and so on. Read it in, copy one to the other, and print out the second one. Okay, so what I'm going to do now is the very first thing I'm going to do is I'm going to rewrite both of these two functions here, read employee and print employee, such that the parameters used are pointers to structures, not structures themselves. This will make our program more efficient. Let's do that first. Okay, so we say this print employee, we're going to take, instead of taking a structure, an emp structure, we're going to take a pointer to an emp structure. Okay, so that's a pretty straightforward change. However, this line will no longer compile because E is not a structure. E is a pointer to a structure. Now there are two ways we could fix this line. The first is to do this, is to dereference the pointer, or find the thing that the pointer points to, and say I want the age field of that. Or there's a simpler way of doing it, just put in the pointer or the arrow operator. Okay, so that's printEmp changed. That's all there is to it. Obviously, if we were going to reference all the other fields of the structure up here, then we would have to just simply repeat the process for each one of those other fields. Now, up here, it's slightly different because readEmp does not even take a parameter at all. It takes no parameters, but it passes back an employee structure as its return value. Now that is just as inefficient as taking a parameter, an employee structure parameter. It's just as inefficient because we have to create a duplicate here. We have to create a duplicate structure, and then this statement here that says return E, that actually does a great big copy. It copies this entire structure here and puts it into this entire structure here. So that's a great big structure copy, and that can be inefficient. So I don't want to do that. I don't want readEmp to take a return value of an employee structure at all. So I don't want a return statement, and I don't want this line either. In fact, instead, I'm going to put it just the same as printEmp. I'm going to do a pointer to an employee structure, and I'm going to call that E as well. And just the same as we had this line of code here, for exactly the same reasons, I'm going to copy that and put it just here. Now, what about this ampersand? Is that necessary? Well, it is, because I'll put some brackets in. Hopefully that'll make it clearer. Because that, inside the brackets, this bit, that is an integer. Would you agree with that? That E pointed to age is an integer. This is a pointer. This is one of the fields that the pointer points to. One of the fields of the structure that the pointer points to. And that is, well, it's an integer from up here. So everything inside those inner brackets is an integer. Now, you recall that when you use scanf, you have to put an ampersand on the front of any integer that you want to pass in. So I'll put the brackets there just to make sure that that's how it's being evaluated. Everything's being evaluated in the correct order. So that will now work. However, we've changed the functions, but we haven't changed how the functions are used down here. So readEmp now does not take a return value. In other words, it has a parameter, and the parameter is, well, it's going to be emp1, but it's not going to be emp1 just like that, because I want to take the address of it. I'm going to pass in the address of emp1. Now notice an interesting side effect here. We're passing in the address of a structure that allows the function involved to change that structure. Recall that? Because we're passing in the address of something, it actually gives the function the power to change that particular thing that we're passing in by simply going to where that pointer points to and changing the object at that particular address. And we've got to do exactly the same thing here to printEmp. We've got to put an ampersand there. Now again, we're passing in the address of a structure, but in this case, printEmp does not change the structure. It could change the structure, but it doesn't. It chooses not to. It's a printing function, and it has the power to change the structure, but it doesn't change the structure. This line of code here, well, we can keep that as it is. That's a structure copy. We can leave that. That's fine. So let's check that it's working. We should be able to simply enter an age, and then it will print out that exact age that we entered. Now, that'll be a very simple output to look at, but if it works, it'll be proving several things. It'll be proving that we can pass an employee structure in as a pointer to one. We can pass the address of one in, and we can dereference that, and we can find one of the fields of that. And again, it proves exactly the same thing here. So it's quite a complex test, even though the results will be quite simple. Let's try and run that. No errors. and please enter the age, 23, age is 23. So all of that is working. Okay, you might like to open up struct.c in the chapter 13 folder and have a look at this code. Study it closely until you get it, because it's very important that you do get it. This is a very important concept, the concept of pointers. This chapter is focused on basic pointers, and in future chapters we're going to have a look at some advanced pointers. Now obviously we're not going to be able to look at advanced pointers unless you get it with basic pointers. So I really strongly encourage you to do all the exercises in this chapter. Really, I can't stress that highly enough. If you don't do these exercises, you'll think that you'll have got it with pointers, but you won't have got it with pointers. It's one thing thinking that you've got it in your head, and there's another thing actually trying to do it. So I'm going to set some exercises carefully designed to make sure that you do actually get